There we go. Welcome everyone to the Symbio Solution Series 2023. Let's jump into it. So today's session is going to be on how to best implement data tables. My name is Dan Vasilini. I'm the VP of Global Sales over here at Symbio, and doing most of the talking today will be Chiara Bondi, one of our solution engineers. Before we get started, just a few housekeeping items so everyone's aware. Today's session will be recorded for replay purposes. Usually we have the session up on our webpage within 24 hours or so after we're finished with the session. So if you'd like to go back and review the session after we're done, or if you'd like to refer it on to a colleague or a friend, it'll be on Symbio.com. Also, please note that everyone will be entered on mute today, so you will not be able to ask a question, or we won't be able to hear you if you want to ask a question. The best way to ask questions is on the right side of your screen generally, but if you've moved it around, it might be the left side or center or wherever. There should be a GoToWebinar dashboard. In that dashboard, there is a question area. In that question area, you are able to type in your questions. Any questions typed in today during the session, we will do our best to get to those, and we will try to answer them as we go. Our session today is scheduled to last about 60 minutes. I think the presentation will probably go about 35 to 40 minutes, so we should have time at the end for questions today if questions do come up. So when the questions are asked, we will get to them as we are going. Upcoming sessions, just so everyone's aware. So announced last time for this year here in 2023, we are doing all sessions on the second Friday of each month, and we're going to do one session per month. So our next two sessions are officially scheduled for May the 12th, Understanding Row References Hierarchy. It'll be a kind of a piggybacking event on top of today's session. So if you're here at today's session, or if you're watching today's session on recording, I'd recommend you come back for the 12th. And then that's May the 12th. And then on Friday, June the 9th, we will be talking about the digital continuum, something that is near and dear here to the Symbio heart. So be on the alert for those two. And then we will be announcing our July, August sessions here very shortly after that. One other thing, if you are aware or aren't aware, we did hold our annual user conference about a month and a half ago. Symbio Sync was held online. If you weren't able to attend, or if you were able to attend and want to go back and review any of the presentations, they are all available at this link located here, or you can go to the Symbio webpage and get to the link that way. But we have presentations from McDonald's, Alcoa, Bristol-Myers Squibb, Northrop Grumman, etc. Some very good presentations in there. I'd highly recommend, if you weren't able to attend live, to go back and view some of those. Each presentation is in the neighborhood of, let's say, 30 to 45 minutes long, and with some live question and answers that occurred after the sessions were over. So it's located there. I recommend you go and watch if you are indeed interested. That said, Chiara, I will turn the presentation over to you. Let me make you the presenter, and the session is yours to go.
Okay. Awesome. Thank you very much, Dan, and thank you everyone for joining us. So I'm going to start sharing my screen. Can you confirm that, Dan, what you're seeing is a Symbio window?
Yep, looks good.
Okay, awesome, fabulous. So today we're going to be diving into data tables, and specifically utilizing this example model that I have put together. We're going to be really understanding the value of using defining foreign keys and primary keys, and really highlighting the power of relational tables in a model. So I'm going to set the stage here of what we currently have. And we have a simple model illustrating a manufacturing facility with incoming orders. And these orders are following an arrival table that I have defined. And all of these orders actually have a set of attributes that define potentially its size, what type of part or order it is. It could be, automatic, hybrid, or manual, a specific code associated with, and then a specific destination. And in this model, once these orders arrive, they will undergo some series of tests here. And then from here, it's where they need to go to one of our packaging stations before they can get shipped out to their assigned destination. However, when trying to decide what packing destination to go through, each one of these machines will use actually a different processing time, or a different time to pack and then get shipped, because Potentially we have one machine that is very new, one an automatic, so it'll automatically pack product and then ship it. Another one that's, maybe older, so it runs a little bit slower. And then we have finally one machine that is manual and will require the use of a worker. So in this example model, what we really want to do is in this testing station, based on the product's attributes as well as the load associated currently for that particular packing machine, we're going to be using a data table to pick the correct or the best station to make sure that we are balancing the workload for all three stations. Because we don't want to send all of our orders to the automatic packing station, because then we're not using all the others that potentially would allow us to ship more product. Don't want to overload any individual machine, whether that be the manual or any of the automatics. And so that's what is going to be occurring in the testing station here. And as I mentioned, what we're going to be doing is actually looking at a data table. So in this data table, we have defined all of the different combinations of our orders with all of their defined attributes, as well as a particular multiplier that we're going to be searching through to understand what is the best packing station to ship this particular order. Now, one thing to note is no combination of these is unique, in that all these orders coming in, we could have multiple orders of the same size, type, code, and destination arriving into our facility. So that process of searching through this data table, understanding what the current workload associated to each individual station, and then deciding where to send it to, is done in process logic. So it is in this particular process logic where right here in this search step, we are searching through the table based on our series of attributes associated to the order, as well as our multiplier and that station's current load, to search and find the next best station to send our order and have it packed and then shipped. So you'll see here that before we even search through this data table, I currently have a notify step. And what this is going to show us is allow us to see when we're doing this search step and we're looking through all possible candidates, how many rows we're going to be looking through. So this data table contains 756 rows. So when I run the model, you'll see that after they do some testing, we currently are going to be looking at 756 rows. What this means is when this particular order is trying to understand where to go, it is looking through the entirety of this data table, matching, trying to find which station is best suited for its size, type, code, and destination. So matching all four attributes and then balancing which station has the smallest workload, which again is represented by this multiplier. And so when we keep running it, I'm going to actually go into the process and leave this notify step, but instead of having it as a warning, I'm going to switch it to a trace. And what this really allows us to do is see here as the model runs, this notify step you can see down here in the trace window kind of pop up, so we can see for all different orders how many rows it's going to be considering as the model runs. So as I run it, the next order comes in, and you can see all of them are going to be searching through all 756 rows. So we'll have all these different orders. Specifically, we're going to have 2,000 orders, each one searching through 756 rows. And so when we run the whole model, my runtime is going to be 24 hours. I'm going to run this whole thing. just to see how long it's going to take to complete. So what I have here is this little floor label where I'm actually going to be showcasing from start to finish how long it takes for the model to run. So if I fast forward, to run the whole model, which again was just a day, took about 2.2 seconds, which isn't a lot. But this again is a fairly simple model. And so having this exhaustive search through 756 rows isn't taking that long, but if we increase the number of rows or increase the complexity, it could take a few more seconds to run. And so how can we now use these attributes and how can we utilize them to maybe make our search a little bit more efficient? So not have to search through 756 rows constantly, but maybe limiting our available row count or the rows that we're looking through based on these set of attributes. And that's really where we're able to utilize and understand the use of primary and foreign keys. Now, before I transition into the next model, I just want to see, Dan, if there's any questions that have come up on this particular example before I switch over to the next one.
No questions yet, Kiara.
Okay, fabulous. So I'm now going to transition to this next model. Same exact setup. We have our orders arriving with the same exact arrival table. So the same exact arrival table, the same exact table that we're going to then be searching through. However, the one difference that appears in this table, in this model, that we didn't have before was the definition of primary keys and the use of relational tables. So you can see here in our work location table, we have this little key icon appearing next to size, type, code, and destination, as well as station. And what this is a foreign key, which allows us to build a bridge and point back to what we would call a primary key. So in our initial model, I had just defined everything directly in our arrival table. So the size, code, destination, type, everything is just defined in the arrival table here. Whereas in this second model, I took the time to define individual tables where I'm specifying the possible sizes, codes, destinations, and table types. And these are going to be our primary keys that we use to build these relationships between this particular table and then all of its primary keys. So what this then allows us is to build this bridge between, say, this particular table of work locations and right here, for example, where we're using a size 50, we're pointing back to our sizes table and we're looking at this specific row. And in fact, thanks to the use of these relational tables, we get what we call a master detail view. And what this allows us is to see in any other table where this key value is being used, what tables it's being used and what other rows it's being used in. So here, for example, we can see that in our work location table, out of 756 rows, 108 of them will have the size 50 value. So why is this important? How does this bridge between and this connection, this relationship between our primary keys and our data table here, how does that help? Well, it helps when we're looking into our process logic in narrowing down what rows we are actually interested in. So in our first model, when we were looking through the data table, we knew, for example, that we were looking for the particular rows corresponding to size 50. However, when we're looking through the table, we'll still be searching and considering as potential options rows that we already know wouldn't be possible because the size doesn't match. For example, this one right here, we know that this isn't feasible because the size isn't 50, it's 150. And the use of foreign keys and building those relationships allows us to, when searching, only focusing in on the rows or pieces of or attributes that we are actually interested in. So if we're looking at a particular order with size 50, we won't even be considering any row that's associated to an order of size 150 because we already know, thanks to these keys, that that's not of interest. Now, similarly, I've put in here different notify steps to really be able to showcase what I mean by this. So when I start running the model, and this, as I mentioned before, works exactly the same. Our orders are going to undergo some testing and then search through that data table to understand which packing station is the best one to send our order to minimize the workload or our multiplier that I've defined in that data table before being shipped out. So if I run, I'm going to pause right here, we can see that when our very first order arrived, it started out by searching through 756 rows. However, in our process logic, because we're utilizing then our set row steps to really narrow down in our primary key tables, or in our tables where we've defined our primary keys, really narrow down on which value, let's say, of the attributes we're actually interested in, we're able to really narrow down and minimize the number of rows that we would be searching through. So in our first order that's arriving, which will contain a particular set of properties, at first we're looking at the entire table. So first we have this entire table. And then through our set row, where we're looking at our primary key, focusing in on our order's size, we're now able to say, thanks to this master detailed view, like, okay, I don't care about anything else that's not size 50. So now this is going to be the table that I'm going to be searching through. And you can see that this has 108 rows, and in fact, our available row count is 108 rows. And then next, we're going to be, again, doing the same exact process, but now narrowing down the code. So what code am I searching through that's relevant to my particular order? And again, it's going to be looking at this particular table, and now it's narrowing down not just by size, but also by code. So right here, for example, we can see all of the different rows where it's using this particular code associated to our order. But instead of looking at all of them, let's see if I can reach only the 50s. Oh, we're now looking at 27 because we're only focusing in on the size that's been defined and the code that's been defined. And this will keep on going for all of our defined attributes in our arrival table. And so you can see at the end, when we reach our search step, which will search again by search through the entire table or the available rows that are left in our table by minimizing our expression, we're only looking at 3 rows. We're no longer searching through 756. We are now just looking at 3 rows. And so let me stop this and actually run now the entire model from start to finish for the 24 hours. So if you remember, the very first model through our exhaustive search took about 2.24 seconds. When I run this, it took just over half a second. So thanks to the use of these foreign keys and building this relationship and building this connection between our table that we're searching through and these primary keys, it allows us to narrow down and not search 756 rows 2,000 times, but instead we're now searching through 3 rows 2,000 times. And this really speeds up and makes the search through those data tables significantly more efficient. So as we saw, we were able to cut down, for example, this particular model's time from 2.3 seconds to just over half a second. I'm going to pause for a second then and see if there's any other questions that have popped up.
So the one question in the box right now, Kiara, is this model that you're working on, is this something you'll be able to share or we could put out there so people can play around with it on their own?
I can definitely provide this model and share it. There is an example model that I will illustrate at the end that really goes into a lot more depth on the use of foreign keys and building these relational tables that I'll touch on at the end as well. But if this is a model that's of interest to be able to share with someone, I can definitely provide that information and provide the model.
And what we've done in the past as well, just for the audience member that asked the question and for anyone else that might be attending either live or on record, we have published the models along next to the actual recording. So be on the lookout for that. Another question that just popped in. What is the actual search criteria specified to send the entity to a specific packing server?
Yes. So the particular criteria is to be able to firstly match the size, type, size, type, code, and destination that's associated. And then you can see here, we're actually keeping track to understand how many of our individual orders are being shipped to each station. So how many of this particular combination of attributes are going through our efficient automatic station, how many of these particular attributes are going to our maybe older automatic station, and how many are going through the manual. And the way in which then our search is currently defined is, again, this is because we're trying to utilize data tables, is through this multiplier and right here, I'm going to actually just show here in the search expression, it's a combination of the multiplier and the current allocation queue waiting at that particular server. And this multiplier that I have defined is defined then updated here, and it's a product of how many entities of that particular or how many orders of those with those particular attributes have been sent to that location times the processing time. And the reason for that is because, as I mentioned, we're going to want to send a lot of orders, for example, to the automatic station because that's going to be significantly faster. But if we send all of them there, we're going to cause a bottleneck. It's going to be overworked. So trying to balance the stations that are going to be working for a much longer period of time with the ones that are going to be a lot more efficient, but making sure that they're still equally utilized throughout the run, that's where this multiplier is really coming into play.
Great. One more question right now, Kiara, and then you can jump into your next thing. Are there other advantages of using this technique rather than reducing the time and computational power to run the simulation?
So other benefits of utilizing, for example, the row for key.
Yes.
Or these foreign keys. So another great way, I'm actually then going to showcase this in our discrete per production example. This is an example model that's actually available to all users of the software. It's available in our support examples. And one of the key benefits of using foreign keys and relational tables is not only does it allow you to, that's not the tab I wanted to go on, there we go. So not only does it allow you to narrow down the candidate rows that you might be searching through, but it then allows you to get all of the information available in your primary key table. So here, for example, you can see in our resources, we have this primary key defined. Now, an important thing to note is that a primary key, as is defined right here, must contain all unique entries. So you can see here that all of these different entries are unique. There's no repetitions. However, when being used in a different table and building in a relational table and building this connection, there they can be used multiple times. But when defined in a primary key, they must be unique. And when using these relational tables and being able to point back to, say, this particular row, not only are you pointing back to this individual column, but you now have access to all of this information. So this allows the user to potentially store a lot of other information, say in this particular data table, where we have a primary key table column for our material name. When you have a data table that points back to, say, finished good A, not only do you know, oh, my material element is finished good A, but you also know its display category, its material class, infinite availability, whether it's true or false, material cost, material color, and any other properties that you have defined in this table. And that is really, really powerful when trying to access a lot of information, maybe of orders or materials or any other object or element that's present in your model.
Good stuff. One more question, Kiara. I think it's a quick answer, then you can jump into your next model. Do all the foreign keys need to be in different tables, or could they be put in one table?
So the best way to use them is to define your primary keys in different tables. And the reason for that is because when we try then to narrow down to, because as I mentioned, for example, your primary key must be unique, right? So if you say you've defined your resources and material names in the same table, you are not able to narrow down potentially a combination of material and resource that you're actually utilizing, because in your primary key table, you've only used them, you have defined a very specific combination. And so what that really means is when you've defined, say, maybe this will be a little bit clearer if I show this right here. So if I had defined, for example, codes and size in the same exact table, and I wanted to narrow down an order that had, maybe size 50, but a code that's not the one corresponding in this table, or function in trying to find that pointer would actually return a 0. It would return no reference, because when we're narrowing down, we aren't able to narrow down both combinations or both primary key values. So the best practice is to have the primary keys defined all in different tables.
Great. All right, I've got a few more questions in the queue, but let's go ahead to the next model and we'll save these till the end, okay?
Yeah, absolutely. So in the last model, what I'm really highlighting is we can see here, for example, in my arrival table, I'm still just defining these kind of individually without, you can see that there's no reference to the primary keys in the arrival table. And so in my processes, or in the process where I then narrow down the possible row count, I still need to go through these steps of setting that reference and building that little connection between the table and the primary key, so that then I can narrow it down. And so in this last model, again, same exact setup, same arrival table, same process, but we can see that I've been able to here, there's no set row steps, there's nothing going on here, and my search step also doesn't have a match condition. And the reason for that is because I have now been able to build that connection and define these foreign keys directly into my arrival table. And what this allows is for every order that's now going to be created following this particular table will have a reference. We'll know basically what row and all of its own attributes. But thanks to the use of foreign keys, every order since the second that it's been created will have a pointer that's going to be telling it, oh, in the primary key, you're interested in size 50. In the code key, you're interested in code EF112 in destinations, distribution center, and type automatic. So we no longer need to go through this, not manual, but this extra step of defining those connections and defining those rows that we're interested in, because our order, when it gets created, automatically has those connections known to it. And so if I fast forward, and again, I'm actually going to illustrate this actually before when I run, you can see that when it starts, it doesn't even go through even contemplating searching through 756 rows. It automatically understands, oh, I'm only interested in 3 of these rows. I'm not interested in any of the other ones because I already know exactly what I'm looking for based on my attributes. And so let me stop here for a second. And when I fast forward, we can see that it was even slightly faster than our first model. So our first model took, or our second model, excuse me. So we went from, let me see actually if I can run it back. So we went from 2.3 seconds, then here 0.56 seconds, and now 0.47 seconds. And that's all through the use of these foreign keys and building these pointers to really interconnect this information, so that every order coming in already knows, I don't care about most of these rows. Most of these rows don't apply to me, and I don't care about them. All I want to know is the ones that apply to me based on these attributes. And if you want to dive into the use of these foreign keys and how to build these relational tables, we have this discrete pair production model, and this comes with a really useful PDF kind of describing it and describing a lot of its different properties and a lot of how its functionality, as well as in the help guide, we have a lot of, in our support, we have a lot of other information on relational tables as well. But this is a great template to really see how you're how building these foreign keys and using these primary and foreign keys to build relational tables can help your model narrow down on candidate rows, access a lot more information in a much more efficient way. So, and this again is available to everyone through our examples right here under the support tab. So these are the example models, and I thank you very much for listening, and hopefully if there's any questions, I'm more than happy to answer them. And one last thing that I do want to mention is there will soon be a SymBit that showcases a very similar behavior to this. So until that's available, I can definitely provide this model to anyone who wants to play around with it. But in one of our future releases, there will be an actual SymBit available right here that really utilizes a very similar mechanism in implementing these relational tables and the primary foreign key use in data.
Great. Thank you, Kira. So I have about 4 or 5 questions in the queue right now. If anyone's out there and you'd like to ask a question, as I stated earlier, in your little GoToWebinar box, there's a drop down for questions. Feel free to type your questions in there. Let me go to some of these questions now, Kiara.
Awesome.
So the question just popped up again, and perhaps at the beginning someone had asked for this model, if this model is going to be available. So yes, what we will do is once this session is published on our website, the recording for it, along with the session, we will have a link to download this particular model, so you'll have access to it. So just get that one off the table right now. Next question: how do you know when you should use table key relationships?
question. I guess one of the best ways, or two of the best ways I think, to really know when to use them is when searching through large amounts of data. So, for example, in this particular case, when you're trying to navigate a very large table or even output tables, when you're trying to, say, store information as you go with particular attributes, using their foreign keys to access that row very efficiently can be really beneficial, as well as instead of needing to create, for example, different properties to associated with different potential, stations, materials, etc., having these foreign keys so that you can store those properties just in a data table and not have to create them manually in your properties window, but instead having them all here, all of these different properties defined here, that's where it can be really, really beneficial to use these primary foreign keys so that you can more easily access these properties and not need to create, description for cut 1, description for cut 2 in your definitions, in your properties section here under definitions.
All right, next question. Are there tools that facilitate making these data tables more easily since you need so many in this example?
Sorry, can you repeat the question?
Yeah, are there tools that facilitate making the data tables more easily since you needed so many in this example?
Yeah, absolutely. So these data tables, for example, you can, right here, for example, this particular data table, you can see that it actually has a binding. So I was able to create this data table externally in Excel and then import it. And that's really the best way to build these larger data tables and being able to use a lot of them is building them externally using, Excel. Maybe you have a CSV file. I have personally built data tables using R and then importing them into Simio. And that allows the implementation of these large data tables significantly easier because you're not manually here inserting, 2,000 rows of information. You're doing it externally and then quickly importing it into Simio, making that process a lot faster.
Great. I think you actually just answered this question, or it's a very similar question, but just to confirm. So someone asked, can these tables be stored externally to Simio and be referenced? And I think you just answered that, but if you want to expound any further, feel free.
I'll expand on it a little bit. So right here, you can see this in the views panel right here, we have tables, and then right below it, we have data connectors. And this is where we are able to build these connections, similar to how I like to think of how primary and foreign keys. With foreign keys, you have a connection to the primary key. Here, with these connectors, you have a connection between your data being stored in an Excel or CSV or other sources like a data importer or an MES system, a database, etc., and a connection between that and Simio. So you are able to import that data table and all of that information directly from wherever it's being stored. And what's great is your binding options. So when importing them, you can actually decide whether you want to have a manual import. So you manually decide, yes, I need to import a new data table, or define it automatically. And what this will do is at the beginning of every run, it'll automatically access the data stored wherever you've defined it, and then import it into Simio so that you always have the most up-to-date information, for example, if that is something of interest in your model.
Okay. All right. I can answer part of this question. You'll have to answer their part. But the question, what is the name of the example file and the Simbit file you mentioned that are good examples? Obviously, the Simbit, as Kiara said, is coming shortly. It's not there yet. But from an example file perspective, any thoughts on that?
So where the example is the name of this example?
Yes.
Yeah. So the example, I'm just going to expand it right here. So the example is going to be scheduling discrete part production, and you can see that it's available right here.
All right, perfect.
your examples right here under the support. It's called scheduling discrete part production.
All right, perfect. All right, a couple more questions still in the queue here. Can you please show again what you specified to allow the data table column update values for the last two columns?
Oh, where I update those values?
I believe that's a question, yes. If it's not the question, please, whoever asked it, please chime in, but I think that's the question.
Yeah, no, absolutely. So where I update those values is right here, right after I've decided, okay, where I'm going to be sending my order to. This is where I then update those particular values. And thanks to the search step, I know exactly what row, right here, for example, I know exactly what row I'm going to be looking at. And so what then I do is I know what row I'm referencing. And so I am now able to adjust, okay, how many orders with this combination of attributes have been sent to the station? Let me add one to the counter. And now knowing that I've increased the counter here by one, so quite a few orders potentially have gone to the station, and they're taking, you know, anywhere from 2 minutes to 20 minutes, depending on, again, if it's the upgraded automatic packaging versus the manual labor station. So it is right here where I'm adjusting that multiplier that then gets used in our search combined with the station's number of orders currently waiting to even access it. So there's a lot of different aspects that I'm using here to try and balance the overall workload of these three stations to ensure that they're not just all getting sent to one individual station, but trying to balance out as much as possible the workload for all three.
All right. If we didn't answer your question, whoever typed that in, please feel free to put another question in there or modify it. Two more questions, Kiara. One short, one long. Let's do the short one first. How do objects like a server use relational data tables?
Well, so a server, for example, one way in which a server can use relational tables is, and actually, I think that is best shown in the discrete part production data table. So right here, when you see this advanced option of auto set table row reference. So if true, the element, then the run initialization, the element pointed to by each row on the table will have a table reference to that row. So what this means is now, whenever the run starts, all of these, because I've been able to use also this table row reference for the servers, each server automatically kind of has a reference or points back to this particular row, which means, again, it has access to all of this information. So what work schedule it's working on, its current location in the facility, what type of object it is, etc. So that's where using, for example, this row references for servers can get really, really handy.
All right. Last question in the queue. It's a long one. I'll read it. It's a two-parter question. Okay. What if you don't have the option of searching a table where your foreign key is unique on every row? And would you still be able to use this approach, or would using the starting and ending index in the search function be a better approach?
I guess so. If you're not able to use foreign keys, is that the first part?
Yeah. What if you don't have the option of searching a table where your foreign key is unique on every row?
You don't have the ability to search. That's a great question, as I'm a little bit I'm trying to think. So I would have to get back on that okay. Question, because I don't really I'm sorry, I apologize. I would really need to think about how that could work. I guess that if it's possible to answer is, are you not able to use the search step individually, or are unable to define the keys? I guess would be the question that I would have. is understanding the
What
context.
what I'll do here for that person's question, I'll go ahead and since we're out of questions, let me just grab the control back and let me show our PowerPoint here. Let me just bring up my email address and your email address,
Yes.
so that everyone can see that and they can reach directly out to one of us with this question if indeed you have it. So you should be able to see, I'm not in present mode right now, but at least you can see it's dvasalini@simio.com and it's cbondi@simio.com. So I'll leave this screen up for a second. So if anyone does want to write that down, you can feel free to write it down. And then you can reach directly out to us with your questions. We have no problem responding to those questions.
Absolutely.
Let me check the queue one more time. I think that's all the questions in the queue. We're about 10 minutes early, but I knew we had a lot of questions, so that was great. If anyone has any follow-up questions, I'll leave the screen up here as we end with both of our email addresses. Feel free to reach out to either of us with any questions you may have. As asked a few times, the model that Kiara worked on in this particular session, we will make a point of getting the model uploaded, and it'll be located somewhere on the Simio webpage where the recording for this session will be. So you'll go in, if you see any of the prior Solution Series sessions, if you go to look at them, you'll see a hyperlink to, upload model here or download model here from the session. We will make sure we do something like that for this one. So otherwise, thanks everyone again for your time today. Real quick, let me just flash up our next two sessions. If it would advance, maybe, come on. There we go. So Friday, May 12th will be our next one. It will be a little bit of a piggyback on top of this one, as I stated. And then Friday, June 9th will be the one following up from that one. And then we will post the additional sessions after, hopefully during next session. Thanks everyone for your time today. Thank you for your time, Kiara. And we look forward to seeing everyone again in about a month. Goodbye, everyone.
Thank you, everyone.